The next time that you get into a car, look around and try and spot every piece of safety tech. Seatbelts and airbags might be kind of obvious, but how many airbags do you see? How many other things can you find that might have to do with safety? Safety's at the forefront of the automotive industry, whether you realize it or not. It's in government requirements, it's in commercials, it's on that dealership window sticker, and you might have actually become a little numb to it in 2023. But the story of crash safety is much crazier than you might realize. Automobiles were actually a thing way back in the 1700s, sort of. But it wasn't until 1869 for tragedy to strike. Around this time, automobiles were still considered a little strange and were used more like toys than actual modes of transportation. Mary Ward was on her way back from a party when she fell off her cousin's homemade steam-powered automobile and inadvertently became the world's first. This was the first recorded victim of an automobile accident. Fast forward a couple decades and commercial production of automobiles has begun. This is in like the late 1890s. But it was still very much the Wild West in terms of safety in vehicles. By 1930, though, death rates had surpassed 15 fatalities per 100 million vehicle miles. That really is kind of a meaningless stat for most people, but a line in the sand had been drawn, and we were finally going to do something to address crash safety. That's right. It's time to blow things up! That might not be 100% accurate, but what actually happened is almost more insane, albeit not exactly targeted at auto safety. The big question that needed to be answered, though, was how do you test for human safety without putting people's lives in danger?
How about I do anyway?
Because we know there's only a certain amount of force a human can withstand.
Are you sure about that?
Okay, well, who's gonna volunteer for being in a car crash?
You serious?
Colonel John Paul Stapp was a MD, PhD, Air Force officer, and a flight surgeon. This is the same guy who did the initial 40,000-foot testing for halo jumps and was tasked to simulate aircraft crash and pilot ejection events. The way they decided to test this was through rocket sled testing, and this began in 1947 with 74 total human runs done by 1951, with Stapp being the most frequent volunteer. In 1954, Stapp hit 632 miles an hour, which broke the land speed record at the time. Not only that, it is the highest recorded acceleration survived by a human, measured at 46.2 Gs. This means he went from 632 miles per hour to a dead stop in 1.4 seconds. He also accelerated to 632 miles an hour in only 5 seconds. Interestingly enough, vehicles in modern frontal crash tests of 35 miles per hour experience peak acceleration anywhere between 30 and 45 Gs. These values are similar to Stapp because the time of deceleration is much shorter at around 10 milliseconds. But Stapp sustained 25 Gs of acceleration over an entire second, where that same value might only be a few milliseconds in a crash test. Additionally, safety countermeasures like seatbelts, load limiters, and airbags help reduce the acceleration experienced by the occupant in car crashes. When you look at acceleration, Top Thrill Dragster, a famous roller coaster in Cedar Point, Ohio, launches passengers from 0 to 120 miles an hour in 4 seconds. And this is around 1.4 Gs. If you've ever ridden this in the front row, you know what I'm talking about. It's pretty insane to think somebody survived something this severe. And not only survived, continued to do it. But it wasn't without sacrifice. Through all his tests, Stapp did break many bones, lost fillings from his teeth, and also developed bleeding into his retinas that caused temporary vision loss. How does this all relate to car safety? Well, Stapp went on to work for NHTSA in 1967 and conducted a ton of auto safety research. Through all this, though, the craziest stat is that Stapp somehow lived to be 89 years old. But it wasn't just Stapp. Another prominent guy was Lawrence Patrick. He was a biomechanics professor at Wayne State University who subjected himself to over 400 rocket sleds and 50-pound pendulum impacts to the body, sometimes in front of his students. One of those students, Harold Mertz, actually went on to work for GM and helped develop the Hybrid 3 crash test dummy that's still used today. However, the end was near. People were getting wind of these crazy volunteer tests, and that was pretty much the end.
Now what?
Well, the next best option is deceased individuals, or human cadavers.
Bring out Jennings!
Also known as post-mortem human subjects. This is as close as it gets to a living person. There are lots of moral and ethical issues with this, though.
I'm not dead! What? Nothing? Here's your ninepence. I'm not dead! Yeah. He says he's not dead. Yes, he is.
Including limitations to biological systems, such as lack of air in the lungs, lack of blood flow, a shelf life of the cadaver. You also have to take into account the age of the cadavers and the cause of death. Because let's face it, most cadavers are older and you have more fragile bones, and some of these causes of death can compromise structures which can influence the biomechanics of your results. Cadavers are also supposed to be single use when you think about it, but that didn't stop many people. Cadavers were ran multiple times in a row sometimes, even after fracture of bones. This is just due to availability being tough and approval for cadaver use being a pain in the ass. Remember, these guys were doing 70 plus volunteer tests on rockets, so we're looking for speed and quantity here. Because of all this, they needed another option. So what's the next best thing? Well, that's animals. That's right, you go straight from one ethical dilemma right into another. And this is where things get weird. The goal with animal testing is to find something as similar biologically to humans while reducing the amount of ethical risks possible. Naturally, primates would be the best, but they have the most protections and they cost a lot. Pigs were deemed the most similar in terms of internal structure and size. They were also prevalent and inexpensive. However, that did not stop testing for all kinds of animals in all sorts of scenarios. Like I said, things get weird. We had chimps on rockets, bears on swings, pigs in driver's seats, living animals with anesthesia versus deceased animals. It was all kind of a shit show. And when you factor in the ethics with some groups,
I will shut that shit down.
Animal testing for automotive crash tests really ended in the 90s. And that brings us to crash test dummies. The goal here was to try to replicate PMHS kinematic and kinetic response as best as you can using non-organic material like rubber, metal, and plastic. Another goal being multi-use, meaning no plastic deformation. Also meaning these things are inherently more stiff than PMHS, so transfer functions were used to convert response to be more human-like. The first crash test dummy is Sierra Sam in 1949. This was a 95th percentile male, so he's a big boy. Then in 1971, GM designs the Hybrid 1, and 2 years later, in 1973, releases the Hybrid 2 50th male, and this is the first crash test dummy to comply with the American Federal Motor Vehicle Safety Standard for testing automotive lap and shoulder belts. The Hybrid 3 was released 3 years later, and this included the 5th percentile female, a 50th percentile male, and a 95th percentile male, and this family of ATDs from 1976 is still actually used today. Small adjustments have been done to these over time, including things with just the instrumentation and minor improvements to the ATDs, but the general design is still used today. There have also been newer crash test dummies like the Thor, which was developed in the 1990s and released in 2013. This is more biofidelic when you look at it, and just looking at the response is a little softer in certain areas, but it is a lot more expensive and much more difficult to maintain. Benefits of ATDs just in general, you don't really have to worry about any ethics. These aren't humans. They are multi-use, and we can put them in any environment we want as long as we're willing to pay for the repairs. However, they are only unidirectional, so you have ATDs that are only meant for frontal impacts, ATDs that are only meant for side impacts. And then, again, a limitation is just the fact that we are using non-organic materials to represent an organic anatomy. And that brings us to the final stage, or the next frontier, you might say. Human body modeling. This is a computer model of a human anatomy, which you use to do simulations of real-world accidents. These things are omnidirectional. Theoretically, you can use them in anything you so choose. There's a lot of papers using these in automotive applications, sports applications, military applications, and there is a cost savings when you compare to physical dummies, because it is a simulation, you have to just pay for licenses. And in the modern day safety field, we are doing more and more simulations, even with crash test dummy models. So this is kind of the natural progression of things. Why not just use a virtual human? That's it for this story. Next time you're in your car driving to get groceries, just think about it. It's pretty remarkable how these things are now safe and how it's just second nature to get in one and drive across town.